Cool. Very happy to be here. Thank you for the opportunity to, can present the work. So Interstellar Lab, the mission of the company is, so what, okay, where is that? Okay. No, back. How do I go back? Oh, this one. Okay, cool. Okay, yeah, so what we're trying to do is to help human, well, life become multiplanetary species, and trying to also answer the question of, what's the point of bringing life to another planet if we're not able to protect life that we have on Earth? So what we've been trying at Interstellar is to develop the system, the structure where we can recreate perfect climatic conditions so we can bring life to other planets. And at the same time that we bring life to other planets, we're also looking to protect life that we have on Earth. So our purpose as a company is really to design the system, to build them, and to protect life and help spreading life among the stars. And so we do that on Earth, and this is our terrestrial business model. This is how we can be a company, generate revenue, and attract investors. And at the same time, we prepare for the multiplanetary vision. And our vision is to bring life. So it's not only about, bringing humans to other planets, but it's also kind of caring and protecting, taking with us all the beautiful and biodiversity that we have on this Earth, and be able to deploy that in outer space. The roadmap of the company, so the company started in late 2018. I met some of you guys at the very beginning, just before the company started, you, Elliot. And so basically what we're doing this year, we're bringing our first system on Earth. We've been working on the manufacturing of those pods by 2025, and it might come actually a little bit before, we'll see. We're looking at building the first space garden attached to orbital station. And towards that, I'll explain a little bit more how we're going to do that. We're getting ready to build by 2027 our first greenhouse on the moon, and probably we're going to send them there a few payloads before. And our big vision is, of course, to participate into building by 2030 a full station on Mars, and to bring some life over there. The first system that we've been developing is called the biopod. So EA for Earth, 55, so 55 square meter. That's the total surface. So it's 36 actually feet long and 16 feet high and 16 feet wide. And it's designed as a completely sealed environment. So it's what we call one of the most advanced indoor farm on Earth. So it's been designed so with a completely deployable system. You have a composite base, an airlock at the entrance, and then on top of the floor, we install our growing system. So it's an inflatable structure. So it's made out of ETFE, so it's actually a one fully membrane that we inflate. It's composed also with air cushion, so we create a good isolation system. Inside, so you have all the growing system. We build it so it's modular, so it's aeroponics with a modular rack, so you can actually grow super small plants, and it can go through like pretty high plants. To be fair, then you have a raised floor, and inside the base, this is where you can find all the hardware system. So you have an HVAC, you have a water treatment system, you have a CO2 scrubber, O2 generator, nutrient dosing system, and all of that is inside the composite base. So it's recreate a perfectly sealed environment where we can control all the climatic conditions inside. And so as I said, inside the base, you have all the atmospheric and watering system. So it's fully regenerative. So we were looking at, okay, if we want to build, do small bubbles on the Earth, what's the point of trying to bring tank of CO2 if you want to enrich the level of CO2 inside the dome so you'll be able to accelerate plant growth. So we integrated that with a CO2 scrubber that is actually taking CO2 from the outside atmosphere of the pod to boost the level of CO2 inside the dome, inside the pod. We have a watering system and a water treatment unit inside, so we can take the water that is inside and purify it and reuse it to water the plants. And then on top of it, we put the growing system. So as I said, we can grow a lot of very diverse type of plants. We've been So I'll show some picture of what we've been doing at the lab and how our vision is really to build the biggest catalog of plants and how to grow them. So we use the pod as a tool, and then we give access to our customers to this database of plants. So we provide them the seeds, we provide them with all the recipe to grow the perfect, to recreate the perfect conditions so the plants can grow. So you can imagine the application that you can have in the future in space. Right now, we know we can grow over 300 species inside. We've been mostly focusing on flowers and on root plants because this is where most of our customers are coming from. We also been growing microgreens and berries, and we're increasing the database of plants we can grow inside. So the pod on Earth, we can use it reduces the water consumption. It's a completely sealed environment. So we put the water inside the tank, it goes through the nutrient solution and it mixes with the nutrient solution, and then it goes into the aeroponics, and then we catch the water that is evapotranspirating through the plants and to put that back into the system. Because it's a completely sealed bubble, so it's similar but different than Biosphere 2. The project was actually very inspired by what was built there. But this pod is really focusing toward optimization of the condition, so the plants can grow in the most efficient way. So we can boost the yield because it's pretty high, and we can stack different plants. And also compared to traditional agriculture, it captures CO2. As I was saying, we're not using CO2 tanks. We're taking CO2 from the outside environment, so in situ resources on Earth to boost the level of CO2 inside. We can reduce the energy needs because it's a completely sealed environment, and so no leakages compared to existing greenhouses you'll find on Earth. And the biopod is also a place where we can preserve biodiversity. By recreating any type of climate, we are able to grow endemic species, endangered species, and this is what we've been providing to our partners in the academic world. So we sell the biopods. This is how we make money as a company. So we want to bring life to other planet, want to protect life on Earth, but if you want to build a successful company, you need to find a way to make money and to attract investors. And so the way we're doing it is by building those pods and selling them. So to date, we have our 70 pre-orders. So we're moving into manufacturing right now. It's a good pipe to start. And so we sell the pod at 250K. It was actually pretty cheap for what it is, compared to container farm at around 150K. But they offer 2 times less growing area that we do. So we are like super competitive on the market. Plus we're regenerative, and it just takes a few days to assemble. So if we put one here, for instance, it's just going to take us like a week to assemble everything. And the only thing that you need is access to the grid. We're not taking care of electricity, not with the first product. We're probably going to do in the future, but not with this one. And you see, it's actually pretty big if you look at the size of the human. Most people believe it's much smaller than it is, and so we recreate, and you can do whatever you want. So we've been focusing on tropical climate, but we can do a lot of different stuff. The market on Earth is really, really big, and it's growing. So of course, health and beauty, they're struggling with the sourcing of their components, so we're providing a solution. Food production, of course, we're working with a lot of companies and countries, and especially in the Middle East, to provide a solution to produce food in desert zone. Scientific research, we have a lot of partnership with different universities, and we're building more. They use the biopod. They want the biopod to use it as a tool to figure out how to grow certain species that are completely endangered, but also to optimize future of agriculture. And of course, biodiversity conservation, as you can grow a lot of different type of plants inside. That's the team. It's not all of us, so we're actually almost 30 now. We're a lot of different background. Jim, our CPO, sitting just here. We have a team of agronomists. We do a lot of AI and machine learning as well. So we have a very cool software team. Engineering, mostly coming from aerospace industry. And also design is very important for us, as you notice with the products. All the team is coming from super cool company. Half of our engineering team is coming from SpaceX. So it's a mix. We have 6 different nationalities. Where, as you can tell by my accent, I'm French, but the company is an American company with a French subsidiary next to Paris. Over the past 3 years, so we've been doing a lot of testing. That's Safé in our plant lab next to Paris. We've grown a lot of plants and much more coming. I think the team's just starting growing some cactuses right now. And so just to give you like, in terms of how big the roots can grow inside our system. So it's that's pretty cool. I think it's a cool picture of what we had at the office. So we get very like healthy roots. So it's aeroponics, it's like super thin droplets. So you really don't use that much water nor nutrient solution. And we build this, you don't really see them, but this is our testing units. So we create solid environment and we've been testing different plants. So we know during one day how much light we need to put, the humidity level, the temperature, and we are preparing for the biopod. That's some of our team working right now, actually it's the embedded team. We use a little bit of additive manufacturing in what we do, more specifically to design some of it's a 3D printer, you can see to design some system that we put in our plant lab, because the plants, when they're growing, they need different structure to hold them. This is what you can see inside. So we have actually 3-4 phytotrons right now working at the lab. So we control inside the level of CO2, of temperature, humidity, and we activate, deactivate the different hardware depending on what we want during the day. So the spectrum of light, the humidity, and of course to the cycle of the plant, so we can accelerate the photosynthesis of the plant. This is a little bit more visual on the data and how we collect the data. So what we do is actually we do simulation, we define what's going to be the role, and then everything's automated inside the small structures. So it recreates the condition automatically. Of course, you can control it, but we try to avoid as much as possible human intervention. And so everything's fully automated. So you have the microcontroller that is receiving the data from the sensors inside the pod, and that is triggering or not the hardware. So the air conditioning, the CO2 scrubber, the O2 generator, or the dehumidifier if we need to decrease humidity. So this is passion fruit that we've been growing. This is marigold, this is some vanilla. Vanilla is really hard to grow in aeroponics, and it's doing very well. On the very end, this is a plant called vetiver that is used in the perfume industry, and we've been growing it also very successfully, super happy. Here you can see a gooseberry, baby gooseberry, and in the front, one of our favorite flower, which is called the Madagascar periwinkle, that is used in that is grown by pharmaceutical industry, because inside the leaf there are several molecules. 5 minutes. Several molecules that are used to fight against cancer, and so by recreating the perfect condition inside the pod, we can accelerate the production of those molecules. We're working also on another experiment that might come very soon. So the manufacturing is ongoing of the first structure. So we had several prototypes. So I'm not going to show a lot of the membrane manufacturing, but the material that you can see here is our membrane, is the material we use for our membrane, and the way it's done. So you have a robot that is coming here and just like cutting the membrane in different pieces. Then you give that to another robot that is doing the welding, and then you inflate the membrane. So that's the process of the manufacturing for the base. So we're doing, so the base is made out of composite, we do injection. And so the first step is, of course, to design the mold, and then you can produce several bases. So that's actually the back, the mold for the back of the base. And this is the process of infusion that we've been going through those past weeks. So that's pretty cool. So you just like take the base, then you put, kind of a plastic on top of it, and then you infuse it. And yeah, so, and also to give you in terms of like the size, and that's just the back. And so the base is divided in 5 different pieces, and that's the smallest one. And so they finished this one, they finished the 2 first one. So we're getting everything assembled by the end of June, early July in Paris. So that's this before a little bit of, getting it shiny and pretty. And that's the software to control the biopods. The whole vision will be, for everyone to be able to control the biopod and to grow anything. So we ship the biopod, we put it where you want it to be. You just, plug it in, and then it works by itself. So we provide you with the seeds, and then we take care of the hardware. I mean, we tell the hardware what to do by putting the intelligence inside the pod, so you don't have to take care of anything. So we're unveiling the biopod in Paris, in our facility next to Paris, this November. It's actually going to be finalized early July, but we'll do a lot of testing during the summer. So if you wanna know more, you can just check out the website. Contact us if you want to be part of the unveiling party. I know many of you are going to be at ISC. Other stuff that we do, because of course this product was designed for Earth application, and this is our main focus as a company. But so our goal is, as I said, to bring life in space. So, and we're not taking care of human life, we're taking care of first plants and then other stuff. So we designed a system to produce food, and we are part of the winner of the NASA Deep Space Food Challenge. This one is into prototype. It's going to be at Kennedy Space Center at the end of August, early September. And so it's very similar to Biopod. It's just a completely different form factor. Here you have a combination of different cubes, but same, they're completely environment controlled. So we control CO2, humidity, temperature, and inside you can grow different things. So on these ones, we've been focusing on microgreens and mushrooms. We might do some insects as well. I mean, this is this is why we designed it for. And so, and it's designed as a macro ecological system that is self-supporting. So we use the CO2 from the mushrooms actually to go into the plant unit, because plant like CO2, plant turn the CO2 into oxygen that goes into the insect unit. And so we're balancing all of that. And our vision is really about automation. So try to minimize the intervention of the crew when they're in space, and because thinking also of future mission. I'm not sure you can see it well, but we've been also working on as a next step for us is to go low Earth orbit. So we've been working on the orbital station. We currently have 3 requests for information proposal to design system to be put on a station. We also have a small payload. We didn't talk about that much because it's kind of like a secret project. But eventually it will go in space before the end of this year. It's a super small payload, environmentally controlled, same to grow plants. Voilà, more around this very soon. Of course, we're working with NASA, with CNES, and the European Space Agency for the Artemis program. Our goal is to put one of our greenhouse on the moon. So that's a render. We're not there yet. We're in favor of surface habitats. I know there are a lot of people for lava too, but I think there is room for everybody. And we believe it can be more inspiring to have some greens on the moon. For the future of humanity. We're American company, but we've, as I said, have offices in France. We work cross country, so we're trying to be as much international as possible. NASA, CNES, Dassault, ESA, we're part of 2 space programs, Starburst and Space Founders. We have awesome investors, so we're small. We raise a little bit more than almost 7 million actually, if I count the grants. So we have great investors on board, and they divide in 2 categories, like space VCs and climate tech VC, which is exactly who we are. And yeah, that's us. There are 10 people missing in this picture. That was just before we starting doing a mess in our hangar in Paris and building stuff. But yeah, that's us, Interstellar. Thank you.